I'm not going to go nuts on this stuff. I'm just going to hit a couple of points. This all came, advanced framing actually was OVE. Probably a lot of you have already heard that or know a lot about advanced framing, optimum value engineering. It was a federal government initiative, something that actually came out of a combination of work from the NAHB Research Center and the USDA Forest Products Lab. They really were, they were fearful at the time anyway, as I understand it, that we were going to basically run out of trees. They didn't envision engineered lumber coming into the mix and that there would be almost a sustainable supply of lumber. So they thought we would be running out, so they wanted to reduce the use of lumber while still encouraging it. So the goal was to reduce the amount of wood that went into houses by 10 to 20%. And then that kind of faded away during the 80s. Then on towards the 90s is when it started getting promoted for energy efficiency, less lumber in the walls, more insulation. And then as more and more people realized that the thermal bridging had a big part in the overall energy performance of the building in general, taking, reducing the lumber reduces the thermal bridges. And since the mid to late 90s and early 2000s, a lot of the green building programs, everything from Energy Star, Leave for Homes, ICC 700, and all of the other programs have all incorporated either in whole or in part some of the requirements for using advanced framing. So a few of the resources that I go to, the APA has an advanced framing guide, and then of course the International Residential Code, the Build America program, and then Building Science Corporation, so as well as Fine Home Building and GBA. Lots of resources out there. The major elements are going with 2x6 walls rather than 2x4. Primarily going to 2x6 because when you go to a 2x6 frame, you can do 2-story tall buildings at 24 on center. You can't do that with 2x4s. You can only do 1-story with 2x4s at 24 on center. And then of course, stack framing everything, or in other words, lining everything up from the foundation all the way to the roof rafters, floors, walls, and so on. It's nothing new. This has been documented back to the mid 1800s in different books. This is just an example of one, The American Cottage Builder from 1854, where they were promoting using 2x5 studs, and that would be a full 5 stud, which is probably comparable to our 2x6s today, and going at 19.2. This was at the advent of balloon framing. And just a quick schematic of a balloon frame wall. For those of you who've done balloon framing or taken apart old buildings have noticed that everything stacks up. The studs have the joist right alongside them, sitting on a ledge or a ribbon board. The studs going all the way from the foundation sill up to the top plate of the uppermost wall. And then very infrequently are there structural headers. Often there are no headers at all in those walls. Either the sheathing help to carry the load, or the ledger or the let-in board that holds up the floors. So you see houses framed like this with balloon framing. So there's lots of details in today's advanced framing. I'm just going to go through floors, walls, and roofs and pick off some high spots. But the nice thing about it is you don't have to buy into the whole program. You can pick and choose what you like and disregard what you don't like. First off, if you want to do full stack frame, then you really need to be looking at framing floors at 24 on center. Well, it's commonly done with open web floor trusses. You don't see it quite as much with I-joists, though occasionally that's done. But here's a little section of the code. In the IRC, we can actually pick the span for any of the lumber we want to use for our floor framing for 12 on center, 16, 19.2, and 24. So if you want to incorporate your floor systems at 24 on center using regular dimensional lumber, you can do that. And then of course, all the I-joist companies have schedules for that as well. Where you see most people looking at advanced framing is in the walls, and all the graphics that you usually see are showing walls. And it talks about reducing the number of studs in the walls by 15 to 30%. Now that's done by a combination of things, both increasing the space from 16 on center to 24, but also by yanking out a lot of the superfluous framing that doesn't do anything for us structurally between backers and corners and blocking and things like that. And then by, of course, by minimizing the amount of lumber that goes in the wall, we minimize that thermal bridging. But you can take advanced framing, outside the realm of just the exterior walls and energy performance. I, for years, going back to the late 80s, early 90s, have framed all my interior walls at 24 on center. There's a lot of pushback from framers and drywall hangers about going to 24 on center. And, it's an option. I don't think I need to spend more money than I want. Or I prefer not to spend more money than I need to on framing lumber if I don't have to. So part of my inclination towards going with advanced framing is because I'm a swamp Yankee. Single top plates, this is probably the most controversial part of advanced framing. And of course you don't have to do it, but it is allowed by code. You can go with single top plates. You just have to make sure you do stack everything above that so that you have full load bearing below it, because a double top plate does serve as sort of a miniature header between your studs. So going to single top plate is a concern if you're going to do different floor framing distances than your stud framing. Getting on to corners and backers, in the upper right corner, I've got the old balloon, or the old platform framing type of way to frame a corner, 4-stud corner or 3 studs with blocks in the middle. And the trouble with any time you create those dead cavities is usually they don't get any insulation tucked in there at the framing stage. I remember once we were framing a corner and we finished up on the job one afternoon, came back the next morning, and we heard this scratching noise because everything was quiet early in the morning before we had tools going. We opened up the wall and a crow had flown in there before we put the sheathing on. So it just goes to show we weren't stuffing any insulation in back in the 1980s. So 3-stud corners, California corners become very common, but there are other ways to do those which even reduce the lumber further by that 3rd stud that ends up getting incorporated is really just there to hold the drywall. So instead we can use just some 1x stock, or I'll use some ripped sheathing scraps from window and door openings and tack those onto my wall stud as backer for the drywall, or drywall clips, or you can use just some ladder blocking. For partition backers, where you got interior wall meeting exterior wall, instead of boxing that out like you see in the upper right corner, what we used to call channel backers, and end up with a big hollow spot in there, just putting some 1x or a wide 2x in behind that partition location gives you the backing you need for the drywall. The solution I like the best, and Mike, I don't think you saw it when we did the Pro Home, but I like to pull any of my interior studs and the plates back, or leave them back 3/4 of an inch from the exterior walls, and then we just shoot all of the drywall straight through. So we don't cut our drywall, we run it right through that partition backer. And from my friend Myron Ferguson, who's that drywall guy and writes a lot of articles for Fine Home Building on drywall, he prefers the less lumber as possible in any corner, because he says that's where all of his cracks come from. It's not due to the drywall, it's due to the wood that's in the wall and the seasonal humidity changes that make it shrink and swell, and then all of a sudden you get the problems where the drywall screws pop through. Moving on to headers, site-built or engineered insulated headers, whether you put the foam on the inside or insulation on the inside, the outside, or in the middle, whether they're pre-engineered or site-built, those are a good way to break the thermal bridges that you can see in the scan up here. My favorite headers are skipping headers altogether. In the code section I got listed here, non-bearing walls, you don't have to put any headers in non-bearing, non-structural walls. So that'd be like the gable end walls most commonly. So you just put a flat header board in to frame out that rough opening, king studs on either side, and you're done with it. Box headers are another good way to go, especially if you're using exterior wall sheathing anyway. You can, just by using a nailing schedule and not having any breaks in that sheathing, provided you run the structural access of the sheathing horizontally and not vertically. I mean, you can go vertically or horizontally with sheathing. There are advantages to going different directions, but if you're going to do box headers, you do have to have the strength access going parallel to the header. But just by adding some extra nails to the sheathing on the outside, in many cases, you can span over most common window openings. Here's an example of that. For a 28-foot wide building, that'd be front wall to back wall, 2 stories with a roof supported by an interior wall, with a 15-inch one-sided box header, in other words, just your exterior sheathing nailed at 3 inches on center, you can get up to a 4-foot opening span. So good for most windows and doors unless you're ganging those all together. Rim joist headers, rather than dropping a header onto jack studs, you can incorporate that right into the floor framing, either as the rim joist that's already up there, be it strand board for an I-joist system or some dimensional lumber, or maybe if you got a wide opening like this, we just added an extra LVL in there, a couple of hangers, and then it just allows us to get more insulation in that what ordinarily would be a structural header drop down onto jack studs. There's a new section in the 2015 IRC which outlines all the code requirements for those rim joist floor headers. And then lastly, on roof details, to get better energy performance, and one benefit I like about this is reducing ice dams. Photo on the left is one on a high performance home, the one on the right's an older home, and you can just see the difference. This was taken the same afternoon on the same day during after a pretty snowy winter around here. So of course, raised heel or energy heel trusses, just getting the top cord up off the bottom, and that allows you for whatever loft of insulation you want to put in there if you're going to do it conventionally, or if you're going to be doing stick framing, instead of just dropping the rafters on top of the top plate where the insulation ends up getting kind of squished down where the rafter's sitting over the top plate, you can set that rafter on top of the floor joist. It does take a little extra lumber because you're going to have to put in a rim joist, but it's a way to get a more loft of insulation in there. And is just another detail for a regular Cape style roof where you get the insulation going up through the floor system, rafters on the floor deck, and then the insulation carrying up through the roof. From a performance standpoint, the differences, and this is from an evaluation of R21 in conventionally framed walls, the whole wall performance doesn't, when you get right down to it, doesn't increase a whole tremendous amount. When you look at it from a 2x6 at 16 on center, gives you whole wall, and this is just on a case study, 16.7 is effective R value. When you go 24 on center with double top plates, it gives you an extra 0.6 in your R value, up to 17.3. And then if you go to single top plate, it's quite remarkable. Just by switching from a double to a single, you get another 0.5 on your overall effective R value. So that's probably primarily due to the thermal bridging through the studs and the walls. So I'm just going to throw the question out there. Is advanced framing even worth it? I did it for years. I thought it was a great idea, but as high performance buildings, and particularly with wall framing and different wall systems have gone over the last, say, 15 years with exterior insulation and double wall studs or double stud wall framing, do you really get that much extra bang of insulation by going with advanced framing? You could probably go with 16 on center with exterior insulation, and the overall wall performance isn't going to drop that much versus an advanced frame wall. So that kind of changes the whole thinking of whether or not you want to go to advanced framing. And then if you go to double stud walls, the same thing. And then lastly, I'll leave you with this. One of the things that's come up, which just blew my mind a few years ago when people started bringing it up as a thought experiment, or actually a practice, is putting more wood in walls or in buildings in general as a way to sequester carbon. And here's just a little thing I pulled off of a USDA, U.S. Department of Agriculture, thing about the wonders of wood in buildings, and it talked about sequestering carbon. So maybe we should just be framing our walls with cross-laminated timbers and have solid wood walls and put do insulation in some other fashion so that we can, if we build high performance buildings and we put lots of wood in them and we make them last for several hundred years, we can sequester the carbon. So that's it. That's where I wanted to leave it. Choose your details and, you know, pick and choose and see if it's worth it, if you think it's worth doing the advanced framing.